Next is reactivity with acid and bases. The first one is neutralization. Now when acid and bases they are mixed together, the thing that we get is that is water is formed and a salt is formed. This is called as neutralization. So what we are doing is that is, for example, we are doing an experiment. So we will take 10 ml of dilute HCl, that is hydrochloric acid, in a beaker, and we will keep on adding, that is dilute NaOH, drop by drop, and we will start to record the pH. Then after some time we have to stop adding NaOH. Now when we have to stop is when the color, that is the paper, that is the pH paper, when it becomes, the pH becomes 7, at that time we have to stop adding more NaOH. So now both HCl and NaOH, they dissociate in their aqueous solution, and the addition of the NaOH to HCl solution is like adding a large concentration of OH minus ions to a large concentration of H plus ions. So what happens that H plus ions and OH minus ions, the concentration is there, it increases, and therefore the mixing of the excess of OH minus ions, it combines with the excess of H plus ions and it forms water. And this water molecule, this is the solvent which is formed. So if we will see the reaction, we added acid and we added base. When we mixed acid and base, we got water and salt. Now HCl we took, that is H plus and Cl minus, and we took a base, that is Na and OH minus. So now this is H plus and this is OH minus. So when we add these two things together, the more of OH minus and the excess of H plus, they mix together and it forms H2O and a salt, that is Na and Cl combined, and a salt is formed. Now this is called as neutralization reaction, that is the water is formed, that is known as neutralization. If we'll take in another example of HNO3, so we have H plus and NO3 minus, and we have NaOH minus. So here H plus and OH minus, it combines together and we get H2O, that is water, and we get a salt, that is NaNO3. So this is called the neutralization reaction. Next is the reaction of acids with metal. So what will happen if you add acid on metal? So here we have taken a magnesium ribbon. Magnesium is a metal. Now that we have added HCl. First of all, we have taken a test tube to which we have added magnesium ribbon, and we have taken dilute HCl. Now as you add dilute HCl to the magnesium ribbon, some gas is produced, and because of the gas an explosion is created. So what happens is that the magnesium metal which is there, it reacts with dilute HCl, and because of which an inflammable gas, that is hydrogen, is formed. And during this reaction, the reactive metal, it displaces hydrogen from the acid to release the hydrogen gas. Now at the same time, the metal is converted into basic radical, which combines with the acidic radicals from the acid and to form salt. So that is magnesium, it combines with HCl, so we get MgCl, that is a salt is formed, MgCl2 salt, and we get hydrogen gas. So that gas is here, that is you can see that the gas is there, and if you will even take some burning thing to here, so then it might also give you an explosion. So this is the reaction of acid with metal. So when acids react with metal, they form salt and the hydrogen gas is formed. We can understand this with another example also. Here we have taken zinc granules and we have taken sulfuric acid now. So when zinc granules combine with sulfuric acid, hydrogen gas is evolved, and this gas, it passes through this delivery tube, and this is the soap solution. If you want to know that the gas is passing, you will see some bubbles arises, and if from the gas you will light a candle, you might see that the burning of hydrogen gas, there is a pop-up sound which is formed. So this is the reaction of metals with acid. Next is, that is third one, reaction of acid with metal oxides. That is, for example, oxides are nothing which have O in it. For example, it is CaO or MgO, Fe2O, ZnO. These are called as metal oxides. So when acids react with metal oxides, then we get salt and water. So for example, when Fe2CO3, that is red ferrous oxide, it combines with acid. Now you can take HCl. So when ferrous oxide it combines with acid, we get ferrous chloride, that is FeCl3, and we also get water. So this is the reaction of acid with metal oxide. Next is the reaction of bases with oxides of non-metals. So when bases reacts with oxides of non-metals, we get salt and water. So here you can see that oxides of non-metal, when they react with base, we get what? Salt and water. So for example, when CO2 it reacts with NaOH, when both of these things are combined, we get Na2CO3 and we also get water. So these things are formed when bases reacts with oxides of non-metal. Next is reaction of acid with carbonates and bicarbonates of metal. So now what happened is that we have taken calcium carbonate and we have taken acid. So we have to see what will happen when acid comes in contact with calcium carbonate. So for this we have taken two test tubes. In one we have taken acid. We will be mixing calcium carbonate in this acid. We have attached this test tube to a tube, and in this test tube we have taken lime water. So when acid is mixed with calcium carbonate, carbon dioxide gas is released. So when lime water, that is from here the carbon dioxide gas will pass into the lime water. So when lime water comes in contact with the gas, which is released from the effervescence, it turns milky. And this is the chemical test for carbon dioxide gas. So when lime water turns milky, because of the effervescence, that is the carbon dioxide. So this gas is produced in the reaction of acid with carbonate and bicarbonates of metal. So whenever bicarbonate and carbonate they reacts with acid, so that time we get what? We get carbon dioxide gas. So in this reaction, the precipitate is formed. This is lime water, that is CaOH2, and hydro, that is the carbon dioxide gas. So CaOH2 and carbon dioxide gas, they form a precipitate, that is CaCO3. So this precipitate is formed, that is calcium carbonate, and water is also formed. Next is the different types of salts. Now there can be acidic salts, basic salts, or neutral salt. But how do we come to know? So neutral salts are formed when there is a neutralization reaction between the strong acid and a strong base. That means when strong acid and strong base they combine together, they will give you a neutral salt. So here you can see NaOH, this is a strong base, and HCl, this is a strong acid. When these two combine, we get NaCl, which is a neutral salt, and we also get water. Next is acidic salts. Now how acidic salts are formed? With strong acid and a weak base. So here if you will see HCl, it is a strong acid. NH4OH, it is a weak base. So when these two combine, we get what? We get an acidic salt, that is NH4Cl. Next is basic salt. Basic salt is formed with combination of weak acid and a strong base. So here CH3COH, that is acetic acid, it is a weak acid, and NaOH, it is a strong base. So these two combine and we get what? CH3COO. Na, this is nothing but a basic salt. Next we have again some type of neutral salt can also be formed with weak acid and a weak base, because neutral it is, so it can be formed with strong acid, strong base also, and weak acid and weak base also. So we have a weak acid here, we have a weak base here, and we get a neutral salt here. And if you will see in all of these reactions, as it is neutralization, so that is why water is formed in all of the reactions. So in all of the salts, water is formed along with it.